Assalamualaikum and hi everyone. In today's lesson, you are going to learn the exception to the octet rule. So here we have three exceptions of the octet rule. They are incomplete octet, expanded octet, and odd number of electrons. In the previous lesson, you have learned that atoms will do chemical bonding in order to achieve stability of noble gas configuration, that is, to obey the octet rule. But in some cases, the central atom will disobey the octet rule, di mana central atom will not achieve noble gas configurations of 8 electrons. So, untuk case exception to the octet rule, kita hanya akan measure pada central atom. So, apabila central atom tidak mencapai stability seperti noble gas configuration iaitu dengan mempunyai sebanyak 8 elektron, so this molecule are said to disobey the octet rule. There are three types exceptions to the octet rule. We have incomplete octet, di mana central atom has less than 8 electrons. We have expanded octet, for central atom has more than 8 electrons, and odd number of electrons where the central atom has odd number of electrons. For incomplete octet, central atom has less than 8 electrons, so this is not achieving octet configuration. So central atom that having this incomplete octet comes from group 2 and 13. Okay, they are beryllium, boron, and aluminium. So as you can see from these three elements, they are actually metals. But when they combine with halogen, they will show covalent character. So in this case, apabila beryllium, boron, and aluminium combines with halogen, they will show less metallic character and more covalent character. So since they are showing their covalent character over here, so they will not donate the electron as what metal does, but they will share the electrons. These are the examples of incomplete octet molecules. So we have BCl3, aluminium trichloride, beryllium hydride, and beryllium chloride. So in this case, this boron, aluminium, beryllium will share their valence electrons with terminal atoms to form covalent bonding, even though they are actually metals. But after combining with the halogen, with the chlorine dan juga hydride over here, they will show covalent character, covalent properties. So in this case, they will tend to share their valence electrons with the terminal atoms. Number of electrons surrounding at the central atom is less than 8. Okay, so kurang daripada 8, so ini merujuk kepada incomplete octet. And this molecule is also known as electron deficient compound. Okay, compound yang kekurangan elektron. An incomplete octet compound can accept electron pair to form dative bonding in order to complete their octet. So untuk nak mencapai kestabilan octet untuk setiap incomplete molecule, they can accept electron pair from another molecules yang mempunyai lebihan elektron in order to form dative covalent bonding. So let's see this example. So for beryllium here, boron has 4 electrons. So there are 4 electrons around the central atom. So this molecule is disobey the octet rule kerana central atom tidak cukup octet. Second example, aluminium trichloride. Okay, pun sama. So central atom over here having 2, 4, 6 electrons around them. Okay, so 6 electron around the central atom. So this molecule juga dikenali sebagai incomplete octet. And the last one, BCl3, the central atom here has 2, 4, 6 electrons as well. Okay, pun sama tidak mencapai octet. Okay, so untuk BCl3, boron has 6 electrons around the central atom. So these molecules are the examples of incomplete octet molecule, di mana central atom tidak mempunyai elektron equals to 8 elektron. So they have electrons less than 8. So itu yang akan menyebabkan mereka klasifikasikan sebagai incomplete octet molecule. Let's study the Lewis structure of BF3. So in drawing the Lewis structure of BF3, I will follow the stepwise method like what you have learned in the previous lesson. So from the total valence electrons, we will follow all the steps and you will get this structure as the Lewis structure of BF3. So at the end of the drawing, you will find out that all 24 electrons has been used in order to produce this Lewis structure of BF3. So for the very last step, apa yang awak kena buat adalah you have to make sure all atoms has achieved octet. So as you calculate for this fluorine, so this F sudah mempunyai sebanyak 2, 4, 6, 8 elektron. Okay, so this fluorine is said to be octet. And the same thing goes to the other fluorine atoms, okay, yang identical ini. So kita boleh katakan bahawa semua fluorine atom sudah pun mencapai octet. But for the boron, at the center here, boron has 2, 4, 6 electrons. So in this case, boron has not yet achieved octet. So according to the steps in drawing Lewis structure, if the central atom has not yet achieved octet, kita boleh cuba move the lone pair, okay, ke arah bonding ini. Okay, share this lone pair towards the bonding supaya boron and fluorine will share the electrons and making a new bonding. So, kita cuba buat step tersebut. So, by doing this, kita akan dapat the new Lewis structure at the bottom. So now, between these two Lewis structures, which one is the most acceptable or plausible Lewis structure for BF3? So, to answer that question, you have to calculate the formal charge. For the first structure up there, formal charge of all atoms are 0. And for the structure at the bottom, by using the same formula to calculate formal charge, we will have boron with -1 formal charge, fluorine A 0 formal charge, fluorine B has positive formal charge, and the last fluorine will has 0 formal charge. So by having these values, since fluorine is more electronegative, so it is forbidden to has positive formal charge. Okay, fluorine adalah atom yang lebih elektronegatif, maka fluorine tidak boleh mempunyai positive formal charge. And for the boron pula, boron adalah atom yang kurang elektronegatif, so it is forbidden to has negative formal charge. So, disebabkan oleh dua kekangan ini, maka we cannot accept this structure sebagai Lewis structure of BF3 walaupun kita dapati di sini boron has 2, 4, 6, 8 electrons. Okay, dalam struktur ini walaupun boron telah mencapai octet, tetapi disebabkan oleh nilai formal charge yang tidak konsisten, iaitu di mana more electronegative element has positive formal charge which is forbidden, maka we cannot accept this Lewis structure untuk BF3. So the Lewis structure for BF3 will be this one. Okay, akan tetapi boron at the center here has electron less than 8, iaitu sebanyak 6 elektron. So disebabkan itu BF3 will be classified sebagai incomplete octet. The other exception to octet rule is expanded octet, in which the central atom has more than 8 electrons. So in this case, central atom that involve in expanded octet adalah non-metal elements of period 3 and onwards. So elements of period 1 and period 2 will not be classified as expanded octet. So hanya untuk elements period 3 and onwards sahaja, okay, yang boleh kita klasifikasikan sebagai expanded octet. So electrons surrounding central atom is more than 8 electrons. There could be 10 or even 12 bonding electrons. So apabila jumlah elektron di sekeliling central atom melebihi 8 iaitu sebanyak 10 ataupun 12, so ini yang akan menyebabkan kita klasifikasikan that molecule as having expanded octet. So kenapa boleh jadi begini? Kenapa central atom can has electron surrounding the central more than 8 electrons? Kerana disebabkan oleh existence of empty d orbitals. Okay, kehadiran d orbitals yang kosong. So with the existence of empty d orbitals, so the central atom can do extra bonding melebihi 8 electrons. And in expanded octet, non-metal central atom are bonded to highly electronegative atom. So as you can see in the first structure PCl5 over here, so phosphorus as the central atom has 2, 4, 6, 8 and 10 electrons. Okay, so there are 10 electrons around the central atom. So ini akan menyebabkan this molecule, this central atom, disobey the octet rule. The other structure as F6, so sulfur at the center having 2, 4, 6, 8, 10, 12 electrons. So there are 12 electrons around the central atom sulfur. So again, apabila the bonding electrons melebihi 8, so maka ini yang kita panggil sebagai expanded octet. So untuk expanded octet juga, central atom does not obey octet rule. The next exception to octet rule is odd number electrons. Bilangan electrons ganjil. So we can observe these features in this molecule NO, nitric oxide, and nitrogen dioxide NO2. So elements involved in the formations of the odd number electrons molecules adalah odd numbered group elements that are group 15, iaitu nitrogen, and group 17, chlorine. So in this case, central atom contains odd number of valence electrons. So disebabkan central atom mempunyai odd number of valence electrons, so maka these abnormalities kita panggil sebagai odd number electrons. So this is the Lewis structure for NO, nitric oxide. So as you can see in this structure, nitrogen has 2, 4, 6, 7 electrons surrounding the nitrogen. So bilangan nitrogen, bilangan elektron yang mengelilingi nitrogen adalah ganjil. So ini menyebabkan kita klasifikasikan NO as odd number electrons molecule. And in the other example, which is NO2, so that nitrogen now are having 2, 4, 6, 7 electrons as well. So di sini, okay, ada sebanyak 7 electrons around the nitrogen. Okay, bilangan 7 itu adalah ganjil. So ini juga akan menyebabkan NO2 will be classified as odd number electrons molecule.